So on yesterday's homework, it's really just solving equations, and the goal of solving any equation is to get the letter by itself on one side, get the variable by itself on one side. How do you get rid of something? You do the opposite. The only detail is if you have a square root, you get rid of a square root by doing the opposite of a square root, which is a square. So let's take a look at, let's say, number 3, for example. A lot of people get confused with the fractions. You first want to think about getting j by itself. Now, of course, there's a 5 times the square root of j. You don't want the 5 or the times 5 or the square root. So let's get rid of the 5 times by dividing by 5 and dividing by 5. You're going to have the square root of j equals 1/5. Yay? Now, what do I do to get rid of the square root to just have j? You're going to square it. And what you do to one side, do to the other side. Use parentheses. So now you have j, that's what you want, equals 1/5 squared. What is 1/5 squared? It's simply 1/5 times 1/5, which is actually 1/25. There you go. I almost forgot on this one, actually on every single one of these, whether you get an answer, a nice answer or an ugly answer, you need to check and make sure it works. So you're supposed to take the 1/25, plug it in there. If you did do the square root of 1/25, that really ends up being 1/5. The square root of 1/25 is 1/5, and 1/5 times 5 will give you 1. So that's like a double check right there. But on every single one, you need to double check it, because sometimes, even though it's a nice answer, it's going to be extraneous. It's not going to work when you double check it. So that would be a no solution if it doesn't work. But in this case, it did work. Is there any other questions from this homework? Let's jump to number 17. So this is a radical inequality, different from a radical equation. And you need to follow certain steps on this, on these types of questions, on radical inequalities. Step 1 is set the radicand value to be greater than or equal to 0. The radicand value is the value inside the root. So step 1 is to do x plus 1 has to be positive, has to be greater than or equal to 0. So when you subtract 1 and subtract 1, you'll realize that your x value has to be greater than or equal to -1. So that's kind of like the first part of your answer. Step 2, solve the original radical inequality as if it were an equation. Okay, so I want to go back to the original and I'm going to start solving this thing. First thing to do would be to isolate the square root. So what do I do with this times 4? Divide by 4. It cancels out. What you do to one side, you do to the other side. Divide by 4. So you're going to have a new inequality. It's going to say the square root of x plus 1 is greater than or equal to 3. We don't flip the inequality symbol because we did not divide by a negative. Okay, now what do we do? Square both sides to get rid of the square root. So you're going to have x plus 1 is greater than or equal to 9. And then you subtract 1 on both sides. You're going to have x is greater than or equal to 8. So that's like another part of our answer. So step 3 is to set up a number line and test your values, which means check your answers. Okay, so we're going to do a quick number line right here. And let's put the value -1 right there and +8 right there. So if you look at your first answer, it says x is greater than or equal to -1. Greater than is to the right. And the other one says x is greater than or equal to 8. So greater than is to the right also. So our answer should be in the in the overlap piece. Okay? So think about this. Let me do this in 2 different colors. If I start here and I'm going in this direction forever, and if I start here and I go in this direction forever also, where's the overlap piece? It's only right here. Does that make sense? So what I'm saying is that my answer is only 8 or greater. So my answer is only x is greater than or equal to 8. Only, that's my only answer. So this other piece over here didn't really even come into effect. The x is greater than or equal to -1, Lawrence. Doesn't even work. Okay, now what you need to do is test your answers. Now what I mean by test your answers, pick a point. So like if you pick a point that's in between, like 0, you'll see that it doesn't work. Check it out. Plug in 0 right here into the original. 0 plus 1 is 1. The square root of 1 is 1. 4 times 1 is 4. And 4 is not greater than or equal to 12. So 0 did not work. 0 doesn't work. If you pick a negative number over here, like let's say negative 10, whatever. If you pick negative 10 and plug it in, negative 10 plus 1, that's negative 9. The square root of negative 9 is 3i. You can't compare imaginary numbers with real numbers. So that didn't work either. So the negative 10 didn't work either. The only ones that will work are the ones that are either 8 or greater than 8. So let's test 8. If you pick 8, 8 plus 1 is 9. The square root of 9 is 3. 4 times 3 is 12. It works. Any number greater than 8 will work. So that's what I mean by check your answers. You draw your number line. The overlap piece is your answer. But you need to check and make sure that your answers actually work. Jump to number 20 on your homework. This one's interesting because you first have to do step 1, which is get your radicand value, set it greater than or equal to 0. So you're going to have 2a plus 4 is greater than or equal to 0. And you're going to subtract 4. You're going to have 2a is greater than or equal to negative 4, which means a is greater than or equal to negative 2. Okay, if you divide by 2 on both sides. So this is one part of our answers so far. Now let's go back and actually solve the original. So we're going to divide both sides by negative 1 or multiply both sides by negative 1. The reason why I picked this one is because it's interesting, because when you divide by a negative, you have to flip the inequality symbol. So far you have the square root of 2a plus 4, flip the inequality symbol, and it becomes positive 6. And then you go through and square both sides. You're going to end up with 2a plus 4 less than or equal to 36. And you continue solving. Subtract 4, cancels. You'll have 2a is less than or equal to 32, which means your final answer, if you divide by 2 on both sides, a is less than or equal to 16. Are you with me? I hope so. So you have those two answers. The third and final step is to do a number line and put those answers on a number line. So negative 2, let's put it over here. And what does it say about negative 2? It says a is greater than or equal to negative 2. So greater than or equal to is to the right. And then the other one says a is less than or equal to 16. So if you're at 16, less than or equal to 16 would be to the left. So the overlap piece this way and this way is in this area between the negative 2 and the 16. This is the area. So we're assuming that our answers are in between there, which means that as our final answer we should write as a compound inequality 2, x in the middle, 16 over here, less than, or equal to on both of them. So we're assuming this is our answer, but we still need to check it. We need to test certain values. So how about we test an easy value like the value of 0, which is clearly between them. When you test 0, 2 times 0 is 0. 0 plus 4 is 4, and the square root of 4 is 2. And you end up with negative in front. Negative 2 is greater than negative 6. It's true. Negative 2 is greater than negative 6 because negative 2 is closer to the positive numbers and negative 6 is further away. So negative 2 is greater than negative 6. So the center does work, yes. If you test points on the outside, you'll see that it does not work. So, yeah, so this is your answer.